recognized conference, actually. So the presentation entitled Towards Circular Economy and Sustainability Through Digitalization of Asset Management, giving Reclaim European project as an example. Reclaim here stands for refurbishment and remanufacturing of large industrial equipment. So I divide this presentation into two parts. So in the first part, I am going to highlight the Reclaim project and give a general overview on it. While in the second part of the presentation, I will focus on Aston University contribution at this project and introduce some of the work carrying out by Aston research team within the project. So in brief, Reclaim is a 48 months and 13 million euros European project launched by researchers and industry representative, actually, from 9 European countries to establish solutions for the sake of helping European industry actually to improve productivity and performance across the manufacturing industry, and also to overcome the failure problem of aging machines in the European factories. So for this sake, actually, the project intends basically to formalize ground rules and tools that really enable manufacturers to monitor the health condition of their machines, and also to implement the appropriate measures such as remanufacturing, refurbishment, and upgrading, okay, of their machines to extend their life over a long period of time. So at the end, the ultimate goal of the project is promoting circular economy, which we will discuss in a bit, by reusing the aging machines or machines that are near to the end of their life. This has to be done by integrating high-tech and smart technologies in a platform that enable the manufacturing to do such or to achieve such goal. So this actually, the objective, what we introduce in the objective is essential to be to the industrial sector in Europe. As you may aware that in Europe, the industrial sector is very important in terms of driving the sustainable growth and employment. So almost 80% of exports and 50% of employment capabilities actually comes from industry sector in Europe. So accordingly, and as a consequence of that, the high industrial productivity and efficiency are closely connected with well-functioning and well-maintained equipment, with which clearly indicate actually the critical role, if we say, of the machinery and equipment. So in fact, it is not only Europe facing this problem, but also in the United States, the outdated machinery in use is estimated at almost 40 billion United States dollar, which cause an estimate loss of about 50% billion United States dollar every year. So due to unplanned downtime and maintenance needed resulting from the online failures. So this undoubtedly, highlights the urgent need for businesses and manufacturers to replace the traditional linear economy. As you see, the traditional linear economy currently applied is just based on take, make, and waste. Just making the machine, taking it and use it, and then just dispose it. So this is the traditional, what we call the traditional linear economy model. Okay, that model needs to be improved in order to retain the machine in the loop of the industry as much as we can. And also that showed major effects on the linear economy model showed major effects on the Earth's ecosystem as well. So, and for this reason, besides the reason that to increase the productivity and reduce the cost, together motivated the businesses and related and relative government bodies to find balanced business model that enable closing the loop instead of generating continuous waste. And this is exactly what Reclaim is trying to achieve. So let me just explore with you in brief the Reclaim vision in more details. So Reclaim actually seeks to achieve 100% of reuse of the equipment throughout its life. So through finding flexible and low-cost smart systems that support the life extension of the industrial equipment, actually. So according to that vision, the Reclaim project adopts the circular economy approach, which is depends on retaining the machine into the loop as much as we can by reusing it. So as an alternative or optional approach to the traditional take, make, waste model. So in this case, circular economy approach retain resources needed or try to minimize the resources needed and waste emissions like CO2 emissions, and try to minimize the energy used during the life cycle of the machine and keep the material and the equipment reused in the loop for longer period of time. So, and this can be achieved through long-lasting design, repair, remanufacturing, and refurbishment of the machine to achieve the ultimate goals, which is, as we said, increasing productivity, environmental friendly, reducing weights and emissions, reuse the production equipment for longer period, and extend the lifetime of the production lines. So this is actually the motivation of using the Reclaim project and within the context of circular economy. So if you look at this graph, which represents the current status of large industrial equipment currently in Europe, okay, that approaches the end of its design life, you can see that exponential increase of the cost, as you see here. That the manufacturer incurred during the lifetime of the equipment. So this coupled with high risk of failure or caused by high risk of failure okay, and very long time needed and unpredictable time needed for the maintenance, in addition to the unavailability of the contact to fix that the problem if happened. So these are the factors that makes the cost increased exponentially, okay, during the lifetime of the heavy equipment in Europe. So what's the solution? So the solution that Reclaim is trying to achieve is adding a new paradigm, or introducing or adopting a new paradigm based on integrated decision support system, or a framework that includes a collection of IoT, Internet of Things, data analytics, and health monitoring to monitor and detect the failure of the machines before it happens, and also to guide the optimal course of action, which is, for example, doing refurbishment, remanufacturing of the equipment to increase the productivity, improve lifetime, and keep costs at constant and minimum level. So this is the solution that Reclaim seeks to achieve at the end. So move a bit to a technical details. As you see, Reclaim solution try to integrate three main layers. So the first layer is the user layer, which include the supporting and advice visualization data and actions. And the second layer include the real-time decision making, which integrates a number of algorithmic algorithmic components that enable making the optimum and real-time decisions. And the third layer is the physical layer, which include all the technological equipment that help supporting the decision for the equipment or to the equipment. So if you see to the architecture, to this architecture level or graph, so as you see in the architecture, so Reclaim integrates several modules actually and components within these three layers. So starting at the physical layer of Reclaim, which supports supported by several pilots to provide the necessary business scenarios on remanufacturing and refurbishment of the machine, stands here. And you can see also all machine operational and historical data, along with life cycle and business models and digital data collected and stored in the Reclaim repository, which is considered the database of the Reclaim, which included all analytics and data needs for the algorithms. So, and then the core Reclaim platform, which include dedicated environment, which consists of three main components: the decision support framework, which supports the decisions through several algorithms designed for this specific task, and in situ repair and data analytics with the refurbishment and remanufacturing frameworks. And finally, you can see in the topmost part of the Reclaim project, of the Reclaim, architecture, the user interfaces, which is supposed to be the manufacturer industries, stands here, and the maintenance support companies that have to support the manufacturers to do their maintenance and life extension of their machines. So again, so this is just a summary of what we said. So Reclaim envisioned to improve the current state of the large industrial equipment stands here in Europe that is near to its end of design life by applying innovative smart solutions and technologies based on data analytics, IoT, and decision support systems to extend the lifetime of the equipment. So we try to move from the current state into Reclaim vision to extend actually the lifetime of the aged machines by applying these collection or integrated services and algorithms. So implementation-wise, here you can see the work package map of Reclaim project and how they relate to each other. I'm not going to go into details of this, but I would like to highlight here the importance of the stakeholder, as you see in the graph here. So stakeholder role is very, very important in order to arrive at a reasonable and meaningful results at the end. Stakeholder involvement, as you see, is highly needed at the requirement analysis, which represent the work package 2, requirement engineering analysis, and also at work package 7, 8, and 9, which include the technology evaluation and acceptance. So the Reclaim project, as you see, as I said, it's launched by 9 European countries. We have in Reclaim 6 use cases that will be used to demonstrate the technologies and solutions produced in Reclaim, which include the refurbishment of robotic cell of dishwasher industry. This comes from Gorenja company or Gorenja pilot in Slovenia. The second use case, which is the refurbishment of white in a milling products, which comes also from Gorenja, from the other branch of Gorenja pilots in Czech. And the third use case, which include the maintenance and upgrading of cutting machines used in shoemaking industry, which comes from Flocho company in Spain. And the fourth use case, which is the predictive maintenance and refurbishment of wood making production line, which comes from Podium company in Switzerland. And the fifth use case, which is the remanufacturing and predictive maintenance of friction welding machines, which comes from Harms and Wende company in Germany. And the last use case, which is the maintenance and refurbishment and upgrading of bleaching machines of textile industry, comes from Zoraltex company in Turkey. So this is the 6 use cases that is going to be demonstrated in use case to validate, demonstrate, and implement all the technologies and solutions that's going to be implemented in Reclaim. So here we can see we have different partners in Reclaim from 9 countries. Actually, in total, there are around 23 partners from research and academic centers, nonprofit organizations, from industrial and small to medium enterprises, and also we have the end users, which called the pilots in Reclaim project that I have mentioned earlier. So the end users are responsible of providing the use cases for demonstrating the Reclaim technologies. So let us move now to give you a quick overview of some of the tasks that we are carrying out at Aston University within the Reclaim project. In brief, Aston University in Reclaim project is considered one actually of the key partners participating in the project, and through the project we are focusing mainly on research side related to methods and algorithms development. So the main area of contribution include life cycle cost modeling and optimization, condition monitoring, smart inspection, and decision support systems. So here I am going to explore some of these applications briefly, and I am not going into much details. However, if anyone is interested in any of these applications, please feel free to contact me at any time to have further discussions about it. So the first application that we have developed in Reclaim is the cost modeling and financial analysis toolkit. So Aston has developed this toolkit service for estimating the cost of life extension strategy that is going to be applied for Reclaim machinery. For example, remanufacturing, refurbishment, and etc. So the output of the cost model will support the decision support framework in order to choose the optimum life extension strategy, as well as the production maintenance planning. So this is the first service that Aston provided to Reclaim project. So this cost modeling actually depends on some other components in Reclaim and receives information such as the list of life extension strategies available to the machine profile indexes, and stop production data, process data, failure types and failure probabilities, and also the outputs of the cost modeling will be integrated or service some other components such as the refurbishment and remanufacturing component, the decision support framework, and life cycle assessment software as well. So another service or another algorithm that Reclaim, that Aston University will provide Reclaim with is the cost-benefit analysis tool. And the cost-benefit analysis tool, we are developing an algorithm that will gauge the economic viability of Reclaim use cases and solutions. So, and determine whether the value and benefit that will be gained from Reclaim solution is worth of the cost required of developing this. So the ultimate goal for this tool is to assess the Reclaim solutions and technologies developed, and to decide the commercialization level, and if the tool is ready to be commercialized or needs any further improvement. So actually what we do, we are trying to gauge the cost or compare the cost against benefits. We try to quantify the costs coming from the development, the hardware deployment, operational and maintenance against the benefits that we will gain through improving the performance, cost savings, time savings, and environmental benefits. So in the end, cost benefit ratio will be obtained for every solution and component within Reclaim. So as I said, so all Reclaim use cases and Reclaim solutions will go through the cost-benefit analysis to assess the economic viability and its readiness for commercialization, actually. So the other tool that Aston University is developing is the life cycle cost optimization and maintenance planning. So we are carrying out this task, and this algorithmic service is designed to provide industrial manufacturer actually with a periodic maintenance plan that will include a recommendation or enable the manufacturer to get a recommendation to the most cost-effective maintenance and action based on integrating sophisticated and detailed analysis of the degradation models of the machine, cost modeling, and after repair improvement models. So all these models will be integrated within the core optimization algorithm, which is the using the genetic algorithms under certain model constraints to allow the user to deeply analyze the status of the machine in terms of cost and degradation profile. This is just a very quick overview of the inputs of the first version of the tool, which include just the users needs to include only a simple information like the starting age and the time period required for the analysis. And the user will get the a number of screens that allow them to navigate and analyze the status of their machines and components. So we will have the summary of the outputs, the summary of the age, starting age and ending age, the detailed analysis of the degradation of the machine over time, and the schedule, the maintenance schedule over the required period of time, and details cost analysis. Another important task that Aston University carrying out in this project is the decision-making for remanufacturing. Actually, remanufacturing has to be made through implementing several processes such as cleaning, painting, welding, heat treatment, for example, machining, metal spraying, and inspection. So the challenge is that facing the manufacturers is that which are the best technique to carry out certain processes in respect of the quality, cost, and time. So for example, the cleaning has many techniques to do. So you can do the cleaning using many techniques. For example, this is just an example, but we have actually more than 15, for example, technique can be used for cleaning. And the same for painting, welding, and etc. So this is a real challenge that facing manufacturers to select or choose or use the best combinations that optimize both all cost, quality, and delivery or time. So Aston University carrying out this task and trying to develop a model that's based on fuzzy scientists' approach to analyze and solve the problem of remanufacturing process selection. So the preliminary model of this algorithm is already devolved and also validated or implemented on a sample of components within the Reclaim project. We have also, we are also implementing some machine learning algorithms within the Reclaim project under the task condition monitoring. So we have also developed and implemented some algorithms for failure detection and fault diagnosis. An example includes this algorithm that you see on the screen, which is based on few-shot fault diagnosis model for rolling bearing and gearbox failure detection. We have also an algorithm based on transfer learning using guided features to deal with the data with varying intervals and limited availability. We have also proposed a digital twins framework for assessing the Reclaim project assets. Such a digital twin actually model helps creating a replica of the planned production process. It's to simulate and enable the engineers to identify any process failures before the project goes into production. So this is actually in brief the overview of what the Reclaim project is, and just an overview and an idea about Aston works within this project. But we are, as we said, we are happy to discuss further for if anyone, I mean, needs or interested in any of the applications that I have introduced. I should thank and acknowledge the team that works with me, which is the Professor Yu Chen, the chair in manufacturing, and Dr. Meng Zhang, research associate, said that we are working in a team in this project to accomplish the tasks that Aston commit to do. So thank you very much for your listening, and happy to answer